Very good morning to all. So I am Dr. Devasis Mohanty, working as assistant professor in the Department of Mathematics, SR University, Warrior. So today I am going to teach about the binomial distribution. So this is very important. The binomial distribution is a discrete probability distribution that models the number of successes. Means we are dealing with basically in binomial distribution the number of success and failure, right? So here it is mentioned success or failure. So either it is dealing with the success or it is dealing with failure. Okay. So here the two possible outcomes are there. Either it is a success for possible outcomes of success or possible outcome of failure. Next, we'll see about the random variable. So random variable basically nothing but that assigns some numerical value to the possible outcomes in a sample space. So here we are taking the probability of success in each trial and the x that random variable that is nearly equals to the that binomial distribution of n and p. So here n that represents the number of success, and p that represent probability of success. That represents the probability of success. So again, 1 minus p, when you are considering the 1 minus p, that represents the probability of failure. Probability of failure. So here nk means nck we are considering that combination of that is the binomial coefficient we are considering here, that n factorial divided by k factorial into n minus k factorial. That formula is very important. Okay. So here we are taking this formula that x equal to k. This formula is very important. This formula is used to calculate the binomial distribution with n number of given n number of trial and fixed the number of k successes. Okay, and p is the probability of success. 1 minus p is the probability of failure in single trial because the number of trial is fixed in case of the binomial distribution. Okay. Next, coming to our point, so as it is dealing with the probability of success and failure, so we are basically considering that we are considering one event or any kind of things. There we will apply only the probability of success and failure. Okay, so this is the main important thing here, that mean and variance, right? So mean that E of x means expectation of x. Here mean is calculated as n into p. N is the number of trials and P is the number of probability of success. And similarly, the variance that varies that represents the variance that is NP whole into 1 minus P. So here NP whole into 1 minus P, that is very important thing. It means N is the NP that mean is multiplied with 1 minus P. That is probability of failure in single trial. Okay, so now coming to the important thing, that is a useful way for students to identify the binomial distribution. So first of all, these are some important points where we can say that this binomial distribution, this is a binomial distribution or not. So how we will check that? The first point is we'll check is the number trial fixed in the advance, and does the is trial have two outcomes. Either we have to check the outcomes are two or not. Either it is the success or failure. Next, are the trials are independent. So we have to check the independent trial. Independent trial means one event does not depending upon the other events. So that we can apply here. And next, also here we have to check the probability of success and the same for every trial or not. Okay, so these are the important aspects that affects the binomial distribution. Okay. So students, next coming to the important example of binomial distribution. Here is one example given. So Rahul is playing a small game during the break. Okay. So here he flips a fair coin of 10 times. So 10 times means n we can take here as 10, right? N is equals to 10. The number of fixed interval means fixed term is 10 times. Okay. Now it getting head is considered a success. So head on this will single flip is 0.5. Okay, 0.5. Then coming to two important things, exactly 5 here. So exactly 5 here means the number of success, the k value, that is equal to 5, right? So now, as we got the n value, the fixed trial, that is 10, and the number of successes is 5. So now we are going to calculate the probability, that is x equals to 5. At that point, we will calculate. So here it is also calculated. What it is calculated? That 10 factorial divided by 5 factorial into 10 minus 5 factorial. That is the combination. We are applying 10 5. That formula we are applying actually n x equals to k, n k, p raised to the power k, 1 minus p raised to the power n minus k. Right? So here it is 10 5 means 10 factorial divided by 5 factorial into 10 minus 5 factorial. Right? Now, after considering this, we are going to use that p raised to the power k. So p is equals to, here p is equals to 0.5, because it is mentioned the probability of success, means probability of getting head in a single play, that is 0.5. Similarly, if p is equal to 0.5, there we can use 1 minus p as that 1 minus 0.5, right? So 1 minus 0.5 raised to the power 10 minus 5. What is 10? 10 is the n. What is 5? 5 is the number of successes, right? So after applying this formula, so here we are getting the value as 252 divided by 1, that is equals to 252 divided by 1024, and the result is 0.246, right? So here we can see the result, that is 0.246. Okay, students. So this is one simple problem that explains the binomial distribution. Means if the n value, means the trial is given 10 times, and with the number of successes, that is k, that is given exactly 5 years. So if exactly 5 years are given, and in the question we have to identify what is the value of p. That is very important. P means number of successes. So here in the question, it is mentioned already. That is 0.5. 0.5 is the number of successes. Fine. Because in the question it is mentioned here in one point, that is a success. Success means they are already mentioned that success is 0.5. So 0.5 raised to the power the value of k, that is we are applying here, that 0.5 raised to the power 5 and 1 minus 0.5 raised to the power 10 minus 5, right? Okay, students. So this is a simple problem. Now we'll go to more deeply that problem. So here is the problem is asking us, a factory uses an automated machine or to manufacture electronic components based on the past record. So here the chance is 10%. Here you can see the chance is 10%. Okay, here is the chance is 10%. So 10% means we can see the 10% that is equal to 0.1. Okay. Now, during an inspection, three items are randomly selected. Three items are selected, so n value is equal to 3, right? Then the supervisor wants to know the likelihood that at most one item. So at most one means maximum one item you can choose there, right? Maximum one item you can choose there. So you need to calculate the probability of x less than equals to 1, right? Okay, the utmost one item. So among the three selected items that turn to be defective. Now we need to find the probability that sample of three items. Okay, utmost one will be defective. So probability of x less than equal to 1 we have to find. So let's come to the solution. So here is the solution. Probability of x less than equal to 5. That is very important. Less than equal to 1. So that is equal to probability of x equals to 0 plus probability of x equals to 1. So generally, this is the probability mass function actually. Why this is we considered here? Because the number of trial is 3 and p value is 0.1. Already I have discussed in the previous slide. So now we need to compute this value, that is important, probability of x equals to 1. So probability of x less than equals to 1, that we can calculate by implementing the previous, that is x equal to 0 plus probability of x equals to 1. Right? Okay, next coming to the solution. So in the first case, we are considering here the probability of x equals to 0. So here is the probability of x equals to 0. That is the number of trial already n value that is equal to 3. And we can consider the k value that is equal to 0 here. So if the n value equals to 3 and k value equals to 0, then we can consider here. Okay. So probability of x equals to 0, we can calculate this value by using 3 0 combining with 0.1 to the power 0, then 1 minus 0.1 raised to the power is 3 minus 0. That is very important. Okay, students. So that is very important actually. Okay. So here we are applying also there. That means the value. Okay. Then next here also we can see the probability of x equals to 1. Next we have to calculate, because we need to calculate the probability of x equals to 0, then probability of x equals to 1. So both we need to calculate. So here we are calculating the probability of x equals to 1. So how we will calculate this? We can calculate this by using that same formula, nk e raised to the power k 1 minus p raised to the power n minus k. Okay, so n is already the value of n is equal to 3, and here as we are calculating the probability at x equals to 1, so we can take the k value as 1, right? So everybody understood? Next, as we are implementing this probability of x equals to 1, so we will take that p1. P1 means the value of nk as p1, and 0.1 to the power 1, 1 minus 0.1 to the power 3 minus 1, right? So we are just implementing the formula here. So after applying this formula, we are getting the result as probability of x equal to 1 is equal to 0.243. So we have already calculated the probability of x equal to 0, that is 0.729, and probability of x equals to 1, that is 0.243. Next, we can compute the probability of x less than equals to 1. And here we will apply the formula probability of x equals to 0 plus probability of x equals to 1. So already we got the probability of x equals to 0, that is 0.729, plus probability of x equals to 1, that is 0.243. So that will get 0.972, right? So this is the final answer. Actually, at most one. At most one is maximum is one. So at most one case we are considering the probability of x less than equal to one. Okay, so x less than equal to one means we'll start the probability of x equals to 0. Then only we will find the probability of x equals to 1. Okay, so this is all about this problem. Next, so this problem is completed. This problem is asking about only to find the probability at most one. So we try to understand the question first. So what the question is asking? What is the probability? So here the question is there. What is the probability that in a sample of 3 items, at most one will be defective? So at most one will be defective means here we need to find the probability of x equals to x is less than equals to 1. And to compute that, we are just calculating x equals to 0 plus x equals to 1. So at 0 and 1 point, we are calculating this, right? So now we can understand that how the binomial distribution we can use to calculate the probability of success and failure, two outcomes. Okay. So if here in the question they mention that at most 3 or at most 2, so we can apply the probability. We can find the probability of x less than equal to 2 also by applying probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Similar method, similar procedure will apply. Okay, so we can calculate at most defective by using the binomial distribution. So now we can see how it is important, how it is means we can use the binomial distribution to compute the probability of success and failure. The defective case also we can compute using the binomial distribution. Okay, students. So this is about the first question, the examples. Okay. So here you can see one thing is x is nearly equals to binomial distribution is 3 and 0.1. Why 3 and 0.1? Because 3 and 0.1. Here 3 is the number of trials. Number of trials. 0.1 is, so here we will consider 0.1. That is what? That is the probability of success. Probability of success. Okay, students. So the K value also here, that is 0.1. Sorry, 0, 1, 2, 3, 4. That values. Okay. Okay, students. So this is the final answer, 0.972. Okay. Now coming to another important example. Now read the question very carefully because this is asking three questions, three sub points are there. Okay. So the question is asking a university library conducts a surprise inspection of written books. Right. From past records, the librarian knows 30% of the written books. So there is 10% means we'll calculate the K value means probability of success where is that 0.1. So here it is 30%. You can see here it is 30%. Right? 30% means the K value is what? 0.3, right? So from the question, you have to drag the information. So it is 30% of the written book have at least one damage phase. Okay. Now the condition of one book is independent of the others. So here one trial is independent of another trial, right? So these are conditions satisfied of Feynman distribution. Okay, students. Next, on a particular day, 8 books are randomly selected for inspection. So now 8 books are selected for in inspection. 8 books. Okay, so what is that 8 value? That is n value. That means the trial that we are considering the books here. Okay, 8 books. So now after reading this information, means from this information we have gathered the information about the K value. That is the number of successes as 0.3 because 30%. And the 8 books means the number of trial. Here the n value we are calculating as 8. Okay. So from this above information, we gather two means n value and k value, right? Okay, students. Okay. So now coming to our question. Our question is asking that the first question: what is the probability that exactly one book is found to be damaged? Exactly one. So students, exactly one means what? What is the meaning of exactly one? Exactly one means here we have to calculate the probability of x equals to one, right? There at most one, at most one. That's why in the previous question we have calculated the probability of x less than equal to one. If it is at least one, so at least means there we have to calculate x greater than that will. So are you getting my point? Okay. So now exactly one case we are calculating the probability of x equals to one, right? So directly we'll apply the formula. Means x equals to one already we know the that in the formula. What is the formula of binomial distribution? Nk, yes, p raised to the power k, 1 minus p raised to the power n minus k. Okay, students. So now here n value is 8. So 8 1 p raised to the, now we have to see the probability of success. Okay. So let's go into the solution. Here you can see probability of success is 0.3. Okay. So here we can write 0.3, that probability of success. That is the 30%, 0.3 to the power k. To the power k here, as we are calculating the probability at x equals to 1. So here that value will be 1, right, students? Next is 1 minus 0.3 raised to the power n minus k. N is 8 minus 1. Okay, students. So by that way only we can calculate here. Okay, that exactly 1. So here 8 1 means here we can see H1. So that is 8C1. Okay. 8C1 means 8 factorial divided by 1 factorial minus 1 factorial. Okay, students. So that is equals to only H. Next, 0.3 to the power 1, that's multiplied by 0.3, then multiplied by 0.08235. Because here we can see that 1 minus 0.3, 1 minus 0.3 is 0.08235. where it is 0.7 raised to the power 8 minus 1. 8 minus 1 is 7. So that is we are getting the value 0.08235. Finally, we are getting the answer that is 0.1976. Okay, students. So here we are applying the probability mass function to calculate the probability of x equals to 1 as 0.1976. Okay, 1976. So this is about only the first question, right? Next, coming to the second question. Next, so I am erasing this because first question already completed. Okay, students. Next, we will do the second question. So here in binomial distribution, in each question you need to concentrate about what they are asking. That is very important. In the first question, exactly means you are just calculating that value probability at x equals to 1, right? Exactly 1. But if the question is like to find at least 1, so at least means in that case, what you will do? Probability of x less than equals to 1. That is how to find that. Already in the previous problem I have discussed how to find probability of x equals to 0 plus probability of x equals to 1, right? Okay. So now we can understand how to calculate the probability, right? So next, in the next question, what is the probability that at least two books are damaged? So that is very important, students. At least two books are damaged. So in case of at least, this is the question actually. At least two. At least two means what? What do we need to calculate? So we have to see here. So just I'm erasing this. Just I'm erasing this. So now let's see about the second question. What the question is asking about. So the question is asking about what is the probability at least two books. At least two books. At least two books. So at least two books means we need to calculate the probability of x at least two. There is at most two. Another case. So at least two means what we need to calculate. X greater than two. That value we need to calculate. Just see the solution. Here probability of x greater than equal to two. Okay, student. Probability of x greater than equal to 2. So here we need to go probability of x greater than equals to 2. We need to calculate. Okay, x greater than equals to 2. So that is 1 minus. So we are calculating the greater value. So whenever we are calculating any greater value, so we have to do the probability 1 minus probability of x less than equals to 2. So there we will apply the probability of x equals to 0 plus probability of x equals to 1. Okay, students. Because we need to calculate at least value. At least value means, so in case of calculating any at least value, so suppose we need to calculate the probability of x greater than equal to 3. So there we will apply 1 minus probability of x less than equal to 3. That less than equal to 3 means we will calculate that is probability of x equals to 0 plus x equals to 1 plus x equals to 2 like that. At least this value. That means at least two value, right? Okay. Everybody understood? Okay. These are very simple concepts actually. So we need to only focus what is the question is asking about. So that is the main motive of the question. Okay. So next we'll see here. Okay, students. So here next we will see what is the probability that at least two books are damaged. So we need to calculate here probability of x greater than equal to 2. To calculate that 1 minus probability of x less than equals to 2. So either you are choosing the lesser value of 2, right? Lesser value of 2 means either you are choosing that's the value that is either x equals to 0 or plus probability of x equals to 1. Okay, students. So already we have done these concepts. So here we are choosing that probability of x equals to 0 and x equals to 1. Okay. So here, first of all, we need to calculate the probability of x equals to 0, right? So probability of x equals to 0, we need to calculate. So by using this, so here, what is the actually the number of trial? What is that? That is 8. That is n value. Okay, that is 8. And after finding the n value, then we need to find the k value. Here, the probability is probability of x equals to 0. So the k value is equal to 0. N value is equal to 8 and k value is equal to 0. Then we will apply the binomial distribution formula. What is the binomial distribution formula? That is nk p raised to the power k 1 minus p raised to the power n minus k. Okay, already I have discussed this formula. So what is p? P is the probability of success. So probability of success is 30% book is written, right? So 30% means probability of success P is equal to 0.3. Okay, students? So P is equal to 0.3. Okay. So now we'll apply this formula. We'll apply this formula. Okay. Just I'm erasing the previous thing so that I can write the solution here. Okay, students. So here we see we have to calculate the probability of x is greater than equals to 2. Okay, students. So probability of x greater than equals to 2. That means 1 minute minus probability of x equals to 0 plus probability of x equals to. Okay, students. So that is equals to. So here we need to calculate the probability of x equals to 0 first. Okay. So probability of x equals to 0 we need to calculate. Okay. So probability of x equals to 0, that is equal to 8 0, that combination p to the power k, right? P is 0.3, right? P to the power k. What is the k value? So here actually the k means the x equal to 0 means that is 0. 1 minus p 0.3. 1 minus 0.2 to the power n minus k. N is 8 minus 0, right? So here that is again I'm writing 8 minus 0. So here 80 means 8 factorial divided by 0 factorial into 8 minus 0 factorial, right? Into 0.3 to the power 1. So that is into 0.3 to the power 1 is 1 and 1 minus 0.3 that is 0.7 raised to the power 8 minus 0 that is 8. Okay, students. So here only probability of x equals to 0 will get the value. You can see here probability of x equals to 0. That is only 1. The value is probability of x equals to 0. That is so 80 is 1, 0.3 to the power 1 is, so here you can see here upper part 0.3 to the power 0 is 1 and then 1 minus 0.3 to the power 8 minus 0, that is what 0.7 to the power 8. This then we'll get the solution, that is 0.0576. Okay, 0.0576. Okay, students, this is the probability of x equals to 0. Okay, so only we are applying the formula actually here to find the probability of x equals to 0, right? So that is 0.0576. That will be right. Okay. So after finding this, we need to find the probability of x equals to 1, right? So here it is not mentioned. So I'll explain how to find the probability of x equals to 1. Probability of x equals to 1. We need to calculate. So how to calculate this probability of x equals to 1? So we already know the formula, that is nk p raised to the power k 1 minus p raised to the power n minus k. So here p equals to p of probability of x equals to 1. So here n value is h, right? 8 1. So then 0.3 to the power, that value, what is that value? 0.3 to the power 1. That means k value. Next 1 minus 0.3. 0.3 to the power n minus k, that is 8 minus 1. Again, we need to calculate. So 8 1 we can calculate, that is 8 factorial divided by 1 factorial into 8 minus 1. Okay, okay students. Next we will see that what is that we'll get. Just I am writing this. Okay. So here we'll get h1 0.3 to the power 1 1 minus 0.3 to the power 8 minus 1. So now this result is we are getting this value 0.1976. Okay, students. So this is about the probability of x equals to 1. So all before that we have already found the probability of x equals to 0, that is 0.0576. After that we are finding the probability of x equals to 1 as 0.1976. So after finding all these values, then we need to calculate the final value. Final value means that probability of x is greater than equals to 2. That value we need to calculate. So that way, for calculating that value, we need to find 1 minus probability of x equal to 0, that is 0.0576, plus probability of x equals to 1, 0.1976. Okay, students. Now this value you will calculate. This value will calculate. What is this value? Now this value is equal to 0.7448. Just calculate this value. 0.0576 plus 0.1976. This 0.0576, that is the probability of x equals to 0, and 0.1976, that is probability of x equals to 1, right? So here the probability of x equals to 1 is 0.1976 and probability of x equal to 0 is 0.0576. Now, coming to the main point, that is 1 minus, sorry, probability of x greater than equal to 2, we need to calculate. So to calculate that, we need to find 1 minus that value. Okay. So this is the value actually. This is the final answer. This is the final answer we are getting 0.7448. So have you verified that, all of you? Okay. Okay, students. So this is actually just about the second question. Second question means how to find the probability of x is greater than equal to 2. Okay. So that is 0.7448. Now, why we need to find the probability of x greater than equal to 2? Because we have to find at least two books. At least two books. That's why we are finding probability of x greater than equal to 2. Okay, students. Okay. Now the third question. That is very important question. So, what is the probability that the number of damaged book is greater than 1 but less than 6? So this question is little bit interesting because between two between two values, two damaged books, we need to find the probability. Means we need to find the probability using the binomial distribution. Okay, using the binomial distribution, we are finding the probability. Okay, students. Now that means what we need to find actually probability of 1 less than x less than 6. So to find the probability between 1 and 6, right? First book, that is 1, that is the book is 1 and the book is 6. So try to understand the question. What is the probability that the number of damaged book is greater than 1 but less than 0, less than 6? So greater than 1 and less than, so here probability of 1 less than x less than 6 to find. So that means here we need to calculate the probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. Right? Try to understand actually as what we need to calculate in the question. So in the question, it has mentioned means between the book 1 and 6, we need to calculate the probability. So using the binomial distribution, 1 to 6 means we have to calculate the probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. Now, as I told you, how to calculate the probability of x equal to 2? Tell me. Yes. So let's see. Probability of x equals to 2 we need to calculate. So using the same formula nk. What is the n value? What is the n value? N value is h, right? What is the k value? K value is 2. So nk. P raised to the power k. 1 minus p raised to the power n minus. So p raised to the power k means. So here we need to compute this. Let's see the solution. Okay. So here p raised to the power p is 0.3. Right? So p is 0.3. P raised to the power k. What is the k value? K value is 2. 1 minus 0.3. 1 minus p raised to the power n minus k. N is 8 minus 2. Okay, students. So 8 to 0.3 to the power 2, 1 minus 0.3 to the power 8 minus 2. That is probability of the probability of x equals to 2. Okay, students. So now we can understand how to find the probability of x equals to 2. Similarly, tell me how to find the probability of x equals to 3. Probability of x equals to 3. That is equal to 8, 3, p raised to the power. P means what is the value of p? What is the value of p? 0.3. P raised to the power k. K is 3. 1 minus 0.3 raised to the power n minus k. 8 minus 3. Okay. So by that way, we can calculate the probability of x equal to 3. Similarly, how to calculate the probability of x equals to 4? That is 8, 4. 0.3 to the power 4. 1 minus 0.3 to the power 8 to the power 8 minus 4. 8. 1 minus p. 1 minus 0.3 to the power 8 minus 4. Okay. So students, here that value 8, 4, that is equals to 8 factorial divided by 4 factorial, 8 minus 4 factorial. Okay, students. So here we need to calculate 0.3 to the power 4. So here 0.3 to the power 4 and also 1 minus 0.3. 1 minus 0.3 means 0.7 to the power 4. We need to calculate also. So similar procedure implement to calculate the probability of x equals to 5. Probability of x equals to 5, that is equals to probability of x equals to 5, that is equal to 8, 5. P raised to the power p is 0.3 to the power 5. 1 minus 0.3 to the power 8 minus 5. Okay, students. So now we can calculate the probability of x equals to 2, x equals to 3, x equal to 4, x equals to 5. So after calculating these all values, hence the probability of x equals to 1. So let's see here, probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. Right? So here, after calculating those values, so you can find the probability that the number of damaged book is greater than 1, but less than 6. Okay, students? So let's see the solution itself. So probability of x equals to 2 here they have calculated, that is equal to 0.2965. It is the probability of x equals to 2. Next, probability of x equals to 3. Probability of x equal to 3 you can calculate. It says 0.3 to the power 3, 1 minus 0.3 to the power 8 minus 3. Okay, students. So that we will calculate here. the value that is 56 multiplied by 0.027 multiplied by 0.16. It is 0.2541. Okay, students. So here we are getting the value of probability of x equal to 2 as 0. So let's see the value. Let's see the probability of x equals to 2. Probability of x equals to 2. So probability, next we will write probability of x equals to 2, that is equal to 0.2965. Probability of x equals to 3, that is 0.2541. Okay. So next, also we have to calculate the probability of x equals to 4. X equals to 4, that is 0.1361. That value we are finding using this binomial distribution. That is also implemented here. Okay, students, so let's see. 8, 4, 0.3 to the power 4, 1 minus 0.3 to the power 8 minus 4. Okay, so that value will get, that is 0. Here will get, here 0.1361. Okay, after calculating the probability of x equal to 4, we have to calculate the probability of x equals to 5. Okay, probability of x equals to 5. Calculate. So probability of x equals to 5 means that we can calculate here 8, 5. 0.3 to the power 5, 1 minus 0.2 to the power 8 minus 5. Okay, so here that result, that is the value actually 0.0467. Okay, 0.0467. Actually, here probability of x equals to 4, that is equals to 0.1361. Already we have found it. We found that value. After that, probability of x equals to 5, we found 0.0467. After calculating this value, so here we will implement this value. So probability of x equals to 4 and probability of x equals to 5. So here also we have that value. We can calculate probability of 1 less than x less than 6. That is equals to probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. Okay. So that value we can calculate 0.7334. Okay, students. 0.7334. So finally, we are getting three type of answers. Means in the first question, we have calculated how we can find that exactly one, right? One item is defective. One item is defective means we found there the value of x equals to 1, that is 0.1976, right? Here it is, we can implement that. So after that, second question, what is the probability that at least two books? So students, at least two books also we have got there at least two books. For at least two books, we have founded the probability of x. At least two means what? Greater than equal to 2. Already we founded that 1 minus probability of x less than equal to 2. Okay, students. Next, in the third question, we found we found probability of 1 less than probability of 1 less than x less than 6. Okay, probability of 1 less than x less than 6. Okay, students. So that we need to calculate the probability of x equals to 2 plus probability of x equals to 3 plus probability of x equals to 4 plus probability of x equals to 5. Okay, students. So this is all about the problem is asking. So whatever, suppose it is asking about find the greater than 2 but less than 5. So greater than 2, less than 5. That means what we need to calculate? If the question is greater than 2 and less than 5, what we need to calculate? Probability of, yes, tell me, 2 less than x less than 5. That means probability of x equals to 3 plus probability of x equals to 4. And whenever you are calculating any probability using the binomial distribution, probability of 3, probability of 4, probability of x equals to 6, any probability, right? we will use the same formula. What is the formula? Probability of x equals to k, that is equals to n k p raised to the power k 1 minus p raised to the power n minus k. That formula is very important, students. So we'll implement that formula to calculate that binomial distribution. Okay, student. So students, now two problems I have explained. So according this, we can solve more problem also. So these are some practice problems for you. These are some homeworks. Okay. So a teacher knows that each student in the class has a means 60% chance. 60% chance. So here you can see that first question, 60% chance of passing the surprise test. The result of different students are independent. If five students are selected at random, what is the probability that exactly three students pass the quiz? So it is very simple. We need to calculate probability of x equals to 3. Just now tell me what is that 60%? There is 30%. That means p value is 0.3. Here it is 60%. That means the value of p is equal to 0.6, right? 0.6. Okay, students. So there here you can see the answer 0.3456. Okay, students. So next 20% of the patients arriving at an emergency ward requires the immediate attention on particular day. 10% arrive independently. So 10% actually arrive independently. So now 20% of the patients arrive at an emergency ward. So 20% of patients arriving emergency ward means. So now we can calculate that 20%. What is that p value? 0.2, 0.2, right? 0.2 is the p value. Next, we immediate attention. 10% patients arrive independently. 10% means there the n value is 10. P value is 0.2. And find exactly 3% require immediate attention. Exactly 3% means what we need to calculate? Exactly 3%. That means probability of x equals to 3. So whenever you are calculating probability of x equals to 3 means the value of k is 3. And at least 2%. At least 2% is what we need to calculate here. At least 2%. At least 2% means probability of, yes, tell me. At least 2 means minimum 2. So x is less than equal to 2. That is probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2. Okay, students. So this is all about the things which we need to apply to solve the problem of binomial distribution. So binomial distribution actually applicable for the fixed number of intervals, and binomial distribution is very applicable to explain the probability of success and failure, right? So here in the question you can see exactly outcome that we can calculate using the binomial distribution. Actually, the distribution, Poisson distribution also there. After this, I'll discuss. So there is average rate constant will be given. Average rate constant lambda. So using that average rate constant with the probability of success, we can calculate the form using the formula lambda to the power k e raised to the power minus lambda divided by k factor n. Probability of x equal to r there we need to calculate. Okay. So these are the distributions. Why these distributions are useful? Because whenever for a huge number, means suppose the students of Warangal, or students of India, like that, huge number of out given sample spaces given. So they are exactly some value whenever you are calculating, you can use that for binomial distribution to calculate the probability of success, means how much success rate we have captured there, how much failure rate we have captured there. So generally in any exam, suppose 100 marks exam is there, right? So in that 100 marks exam, here you can see, in that 100 marks exam, suppose exam is 100 marks. So okay, exam is 100 marks. There is the passing mark is suppose 80. Okay, 80 is the passing mark. So there is we can amplify, we can show there that what is the probability of success. So number of students getting more than 80, right? What is the probability of failure? Number of students getting less than 80. right? So by that way, that is very applicable, that is very important to calculate the binomial distribution. Okay, students, so this is all about the binomial distribution. Thank you for listening. Thank you, students. Thank you so much. Okay, that's all about the binomial distribution. So tomorrow we'll discuss about the Poisson's distribution. Thank you for listening. Thank you. Thank you.